Hello, in this short video I'm going to solve the following A+ level problem for you. It's a problem on the topic of similarity of triangles. In the triangle ABC, the angle B equals to 2 times the angle C. Show that B squared minus C squared is equal to AC. Of course, here as usual in geometry, A means the length of BC, B means the length of AC, and C means the length of AB. Pause the video at this point and give it a try. Okay, so to solve the geometry problem, it's always very helpful to sketch some picture for the problem. Okay, so let us do it here. So here I have a triangle ABC, and then I know that this angle B is twice as large as the angle C. For example, if I call angle C theta, then angle B becomes 2 theta. Okay, in order to solve this problem, I want to use the similarity of triangles, but we do not have two triangles here. Might be that is a good idea if I draw the angle bisector here. First of all, when I draw the angle bisector here, then each one of these angles become theta, and then I will have two triangles, and if you look closely, it is very simple to realize that this triangle that you construct in this way will be similar to the original triangle. Okay, so this is the preliminary observation that we make to solve the problem. So now let us do this. So we draw the angle bisector BD, for example. Okay, so what I will do, I will change my color. I will try to draw this angle bisector here. It's a line segment that divides the angle B into two equal pieces, and I call this BD. And for simplicity, so let us write theta here now, theta here, because the total angle was through theta, and when I draw the angle bisector, each part becomes theta and theta. Okay, something that becomes clear, first of all, you see that this triangle that you construct here is an isosceles triangle now, because this is theta, this is also the same theta. So what does it mean? It means that if I call this x, yes, then this part from C to D also becomes x. So let me call this one x as well. Okay, now the whole length is B, little b, because it is opposite to angle B, we call it B. So what is left for this part is B minus x. So let me write that one as well. So this becomes now B minus x. And now AB from A to B is called little c, and from B to C is of course called little a. But now look, I'm claiming that this triangle here is similar to the original triangle. That is very simple to realize. Why? Because this angle A is the angle in common. It is an angle both for the bigger original triangle and this smaller triangle that we just constructed. On the other hand, the smaller triangle has an angle theta, and the original triangle also has an angle theta. So by angle theorem, these two triangles are similar. Two angles from one triangle are equal in size to two angles of the other triangle. So we have to write it down, okay? So I would say that angle A is equal to angle A, the angle in common, yes, and then I would say that angle ABD from the smaller triangle is equal to angle ACB. Both of them are equal to theta. So from these two, by angle theorem, so let me simplify it by angle theorem, we conclude that triangle ABD is similar to the triangle ABC. Okay, so then I can write the ratio of the corresponding length to be equal. So what I would write, so I would say that from the little one, AD, sorry, which is opposite to angle theta, I will find angle theta here and read the opposite side of the bigger triangle. So if I choose B minus X from the little triangle, I have to divide this by C from the bigger triangle. Okay, this becomes equal to, now if I choose C from the smaller triangle, C is opposite to this angle. Okay, from the bigger triangle, this angle becomes equal to this angle. So this angle becomes equal to, okay, so you see that this angle is definitely equal to this angle, okay, because you can see this is the exterior angle of this triangle, and this angle will be the sum of this and that, which becomes 2 theta, and this one is also 2 theta. So if I write C, which is opposite to this angle from the smaller triangle, I have to go and write the opposite side of the bigger triangle, which is opposite to this 2 theta, which becomes this angle, and that is B. Okay, so I would write is as C over B, and finally the leftovers, X from the smaller triangle over the A from the bigger triangle. Okay, so this is what we get. That's a good thing, but look, here we want to prove a relation in which there is no place for X, yes? But here, unfortunately, X appears here and there. Okay, if I choose these two together, I cannot get rid of X. If I choose these two together, I cannot get rid of X. If I choose these together, I cannot get rid of X. So you shouldn't expect to get rid of X immediately. But you have two equations in which you can write two equations in which X appears, and then from those equations you can eliminate X. For example, let me take these two together first. So what happens from here? A times C is equal to B times X. But divide everything by B, so AC over B becomes X. This is one relation. Okay, now let us take these together. Okay, then what happens? B times the whole combination becomes C times C. So this means that B times B minus X becomes equal to C times C. I multiply B inside the pair of brackets, so it becomes B squared minus BX. On the right hand side, I will have C squared. Okay, but now what I can do, I can take this X with me and put it here. Okay, so I will continue. So this becomes B squared minus B. Instead of X, I put A C over B and equals to C squared. Now what happens, this B and that B are cancelled, and if I go a little bit further, this becomes B squared minus AC equals to C squared. This is essentially what we are supposed to prove. You see, this is the relation that we have. Okay, so what I will do, I move C squared to the left and AC to the right. So B squared is already there. I move C squared to the left, so it becomes minus C squared, but I will move minus AC to the right, so it becomes positive AC. And that is exactly the relation that we were looking to prove. I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.